Okay, let me just get the phone stable there. Projectile motion approach. Okay, what do I mean by this? I just want to quickly discuss an approach to solving the problems, approach to understanding each problem, and how to go about solving it, of course, for projectile motion 12.6. The first thing, okay, the first thing that I would always do, so basically, I'd just like to give you a quick overview of how I go about approaching solving these problems. And then I want to go through a few examples, not in detail, but showing you a general approach, how I go about solving the problems. Perhaps it can help you. If you don't feel it's helping you, that's fine. But I think it might help, okay? So what is the approach? The first thing that I always like to do is break up all the information into my horizontal and vertical information. Okay, so if I'm given a vertical initial velocity, a horizontal initial position, I'm given a horizontal final velocity, all that, right? It's so much information. What I do is I just break it up and I say, okay, what is this item? Oh, it's horizontal information. What's that item? Oh, it's vertical information. It's horizontal position. It's a horizontal velocity. It's a vertical position, vertical velocity, whatever, right? Because recall, that projectile motion, the way that we solve problems is we break it up into its horizontal and vertical directions, and we analyze the motion of the particle in the horizontal and vertical directions. Okay? So that's my step one. Step two, sometimes you know which equation to jump to. Recall that with projectile motion, we break it up into horizontal motion using these two equations. And in the vertical direction, we analyze the motion of the particle using these three equations. Recall that ax is 0, horizontal acceleration is 0, and ay is minus g. Okay, recall that, which means it's a constant acceleration problem. Projectile motion is a constant acceleration problem, which means that we use our constant acceleration equations, and we're left with these 5 bits of information. Okay, so if you've got a problem and you don't know where to start, there's just so much information. Step one, break it up into its horizontal and vertical info. Then systematically, if you don't know where to go, systematically go through each of these equations and ask yourself, does the information I have, apply to an equation, and will that equation lead me further to solve the problem? I take that info, I look at each one, I look at this one, I look at each component, and I see, do I have that information? Will it help me solve the problem? Do I have this information? No. Do I have that? Yes. Do I have that? No. Will it lead me further to solve the problem? Okay? So that's my next bit of advice. Third point is time is the element that links the vertical and the horizontal information. So if the problem only gives us horizontal information, for example, but we want vertical information, or vice versa, we've got vertical, or we might even have both information, but we need something from the vertical direction to give us the horizontal direction. It's time. Okay? Recall that time is the link between horizontal and vertical. And then finally, maybe this doesn't make sense now, but we'll see when we look at one or two examples. The reference frame can be measured from anywhere. What do I mean by that? If we just try to zoom in here, we look at our original diagram in the textbook. Recall, this is our projectile motion. Remember that the vertical direction is measured, in this case, from the horizontal x-axis. So the positions are y0 and y final, y and y0, y final, y initial, and they're measured from the horizontal x-axis. What you need to take note of is that a lot of the problems require information below the x-axis, for example. So you can take your measurements of these vertical positions from the x-axis or from another point that you think might help solve the problem more easily. Okay, so we'll have a look at that. So hopefully this helps you. Number one, break it up into horizontal and vertical information. Go through each equation. Recall that time links vertical and horizontal, and your reference frame can be measured from anywhere. So let's just have a look. I'm not going to go into detail with these problems, but let's just have a look. A sack slides off the ramp. This is 1211 with a horizontal velocity. Oh, I've got some horizontal information. Okay, good. Write it down. If the height of the ramp is 6 meters, oh, what's that? That is some vertical information. So it's 6 meters from the floor. 6 meters from the floor. Determine the time. What is time? Oh, time links vertical and horizontal information to each other. The time needed for the sack to strike the floor. Okay, and what else do we, so we want time, and we're looking for the range where that's the range, right? The range where the sacks begin to pile up. What is range? That's horizontal information. So I've got some horizontal information. I've got some vertical information, and we are looking for time. Okay, so in a very rapid way, write down your information. Okay, I'm not going to do this in the next one, but if you take example 1211, there's example 1211, horizontal information. We've got Vx, or V original in the x, is 12 meters per second. We're looking for the range. That's what we're looking for. We're looking for the range. That's the only horizontal information and requirements we have. Vertical direction. What do we have? We've got the height is 6 meters, and that's it. We've also got, obviously, ay equals minus g. Okay, so there's my horizontal and my vertical information. Now, perhaps you already know how to solve this problem because you're a genius. Okay, I'm not a genius. Let me systematically go through each equation and see if it helps me solve the problem. Okay, our velocity is constant. Does that really help me? No, it doesn't really help me solve the problem. Let's move on. This equation, does it help me solve the problem? Remember, if I move x over, I get x minus x0. And what is x minus x0? That's your range. Recall that x minus x0 is my range. So yes, I'm going to need this equation. All right? So, but the problem is I don't have time. Okay, so I'm just showing you. Let's move on to the next one. Vy, now we're moving to the vertical. These are the vertical equations. V final in the y direction is Vy in the original in the y direction minus gt. Does this help me? Do I have Vy? I don't have Vy final. That's my Vy final. My Vy initial, I do have. That's 0. Do I have t? No, I don't have t. But will this help me? It doesn't look like it'll really help me. I've got two unknowns. Let's move on to the next one. Y, that's my position information, my final. Will that help me? Yes, I'm looking. Well, no, but the point is, do I have it? Yes, I've got it. Do I have it y original? Yes. Okay, recall. There's my y original. There's my y final. Okay, so yes, I've got that information. Do I have my original velocity in the y? Yes. Do I have t? No, that's what I'm looking for. Do I have g? Yes. So this equation, I've got one unknown, and that's time. So I can make use of this, solve for time, and I've basically solved one of the questions. Then I take this time and I put it back into there and I solve for my range. Okay? So I hope that gives you just a bit of an idea of how I go about solving these problems. Let's just look at one more again, just quickly. Let's see here. So the chipping machine is designed to eject wood chips at V0 equals 7.5 meters per second. Remember, that is the resultant velocity. We don't have our Vx and our Vx 0x and our V0y. Okay, so we don't have information here already given to us in the x and y directions. If the tube is oriented at 30 degrees from the horizontal, determine how high. Okay, so what is this? This is vertical information. Okay, here this V0 gives us both horizontal and vertical information. Determine how high H the chips strike the pile if at this instant they land on the pile 6 meters. Horizontal information, I'm looking for vertical information. Okay, so let's break up all the information we have into horizontal and vertical. How would I do that with this? I would say 7.5 cos 30 is my horizontal velocity. 7.5 sine 30 is my vertical velocity. Original, right? And then, what do? I then systematically, if you don't know what to do, systematically go through each of these equations. Okay? And then try to see if you can solve those problems. Okay, so I think I don't want to make this video much longer, but hopefully this has given you some meat to chew on and some kind of approach for solving these problems. Cheers.